So let's take a look at how to find the length of an arc given the central angle and its radius. Before we do that, let's get an understanding of degrees and radians. 360 degrees is a full circle, and so is 2 pi, which means 180 degrees is half a circle, and so is pi. And this could then be your basis to do any conversion from degrees to radians or radians to degrees. So for example, if I have an angle, as in the case like we do, of 45 degrees. So I can say 45 degrees is equal to x, and 180 degrees is equal to pi. And I could just cross multiply, and so I've created a ratio. And so once I've done that, I'm going to get 180x is equal to 45 pi. And so x is equal to 45 pi over 180, which is basically 1/4. 45 into 180 is 1/4, and so x is equal to pi over 4. Of course, this is radians. We have now converted degrees to radians. Now this works both ways. There's something else we want to make sure that we're able to comprehend. The circumference of a circle is 2 pi r. Now, the circumference of a circle is the full length around the circle. Of course, 2 pi is the full circle. This is the angle. So you could also say 360 degrees r. So a half a circle would be 2 pi r over 2. And a fourth of a circle would be 2 pi r over 4. What's really happening here is we're taking the angle and we're putting it over the total. What do I mean by that? So a half a circle would be pi. It would be 180 degrees over 360 degrees multiplied by 2 pi r, multiplied by the full circumference. Or pi divided by 2 pi multiplied by 2 pi r, which is the full circumference. In both cases, you'll end up at 1/2. 180 into 180 is 1. 180 into 360 is 2. So you get 1/2 multiplied by 2 pi r, which is what I said here, which will just give you 2 pi r over 2, which is just pi r. 2 pi r over 2. Similarly here, if you did it in radians, the pi's would cancel and you would end up with 2 pi r over 2, and then the 2's would cancel, you end up with just pi r. And so what we're finding here is actually that part of the circumference that is covered by that angle. So, for example, if you have a circle and it covers this part, this is theta, and this is the radius, what you will have is whatever this angle is over the full circle. In degrees, it would be 360. In radians, it would be 2 pi multiplied by the circumference. Okay, fair enough. Let's see how that works. So here, we're looking to find this length, AB, but the full thing is 2 pi r, that's the circumference. But I'm looking to find a slice of that pi, and I just want to find the distance around the sides of the pi, which is a portion of the circumference. Well, my portion is 45 degrees of the total 360 degrees multiplied by 2 pi r. Now, I could work this like this, or I could convert this right here to radians. So what I'm going to do though is, because I can just cancel right here, is I'm going to say 45 into 45 is 1. And 45 into 360 is 8. And so this leaves me with 2 pi r over 8, which is really pi r over 4. Now, I know what r is. R is 5. So I end up with 5 pi over 4. And this is my answer right here. Now I can plug this into my calculator, and I'm going to get 5 multiplied by 3.14 and so forth, divided by 4, and my unit is going to be meters. But that's my answer. I'm going to get a number right here, and that's my answer. Okay? So what you want to do now is you want to give one a try where you have an angle of 60 degrees and a radius of 10 cm. Go ahead and find that arc length, which is given by S, and put your answer in the comments. If this video was helpful to you, give it a thumbs up, share it, and look out for some more videos.